Hello everyone, welcome back. In this video, I will walk you through the how to debug this buggy.py. I think this is our first ICE but this ICE you don't have to submit on Submit, so you just play around with yourself. Since I'm not here today, so I would like to record a video or walk you guys through this buggy.py. Okay, so you basically imagine you basically got a new job in sort of generic in a corporation, and you are a junior engineer to debug this code. Okay, so this code it is a Python code. It starts with imports of NUMPE, matplotlib, and a factor data. Okay, so what happened here in the factor data is kind of a piece of encoded script that you are not supposed to see. Okay, but what's over there is basically it's translating a bunch of Python code into ASCII format so that you can not really see them. But what's over there is just a bunch of Python code. Okay, so this is the code that I downloaded from the LMS. So if you generally look at, let's generally skim through this code. We have a bunch of functions like compute average, compute bending stress, compute rectangular first moment of area, a bunch of compute functions, and we have this launch code. Okay. Besides the launch code, I think that's it. That's all we have. So this piece of code starting from line 205, this is basically when you directly call this script from terminal, this piece of code will be executed. Basically, whatever within this if and else block will be executed. Okay. Now, the first thing I wanted to talk about, as you can see, it has a lot of, this red dot here. Okay, it says undefined name, get launch code, blah blah blah. Well, that's because it's actually within this factor data. Okay, so you don't have to worry about it, although it says something's wrong, but it's actually fine. Okay, it will be fine. All right, so let's start to so basically in this ICE, what you're gonna do is you are going to first obviously fix some bug of this code. Right now this code it has some bug. You don't have to fix all of them in order to just launch the rocket, but if you want to finish all the task here, you do need to finish. You do need to figure out all the bugs here. Okay. So let's just follow Python. Start with line 206, because that's actually the first place where this Python code is being executed. After it's imported those necessary things, we actually directly start from here. From line 206. All right, so if we generally look at this code, just look within this code block, we find out there are some flags that we can turn them on to switch that we can turn on and turn it on and turn off. So the first task of this ICE is to get the launch code. Launch code, you can think about it's a bunch of password. You want to get the password in order to launch the virtual rocket in this code. In order to do that, well, you need to read carefully about the launch code description. The launch code is only available when using a debugger. In an old manual, you found that the correct value of the launch code is the sum of the get launch code after it has been called 1,000 times and 2,000 times. What does that mean? well, if we look at the code here, okay, so right now it looks like there's a for loop running from 0 to 9,999, and we're going to run this code again. Okay, so what does this mean? I think what it means is we're going to intercept within the for loop, we're going to intercept if after we after this get launch code being called 1,000 times, we need to print out the launch code here, and then we're gonna let the for loop running until it hits 2,000 times. Then we get another launch code. Finally, we will consider the sum of the two launch code, and that should be our final launch code based on the description of this docstring here. Okay, so there are some hint about how you're gonna do this. So you can use something like a breakpoint function. I hope anything has covered this in the lecture. Basically, this is just another way of inserting the breakpoint. Besides inserting breakpoint like this using the IDE Spyder itself, we can also use breakpoint functions. So in order to do that, what we can do is we can just say if I equals to remember. What do you mean by after it has been called 1,000 times? Well, that if I is 0, that means as it has been called once, right? So that means if I has been called 1,000, if get launch code has been called 1,000 times, that means I should be 999. All right. Perhaps some of you have noticed that this code from LMS is actually following the two-space indentation style, which is not recommended. Okay, this is not recommended. This is never recommended for me. However, for some reason, I don't know, it's in the template. But if just for this ICE, because two-space is actually a really old style, and it's no longer recommended, I think, in the in the modern Python. But anyway, let's follow the convention just for this Python script. Okay, so we're going to use two spaces here. Then I'm going to use a breakpoint. Okay, just this breakpoint function. It is equivalent to add a breakpoint right here. Okay. All right. So next I'm going to do is then what it says once you get the value for 1,000 iterations, use the continue command to continue execution. Okay, I'm going to use a continue command here because this is not, I don't want it to stop my iteration. Okay, next one I'm going to do, I'm going to say I'm going to run until it has been called 2,000 times. Okay, I'm adding another breakpoint here. Okay, that's it. This is a piece of code I need, and I believe if I run this, remember this launch code is only available using a debugger. That means if you use this green triangle, it will not work. You have to use this blue triangle here to enable a debugger of this code. Okay, in order to run this piece. Once you run this piece, you get the launch code at each breakpoint, sum them up, write it down on a paper. You will have the launch code, which is basically a password. Okay, so this is basically the general idea to finish our first task. But before that, I want to quickly, fix some obvious bugs. Okay, so one of the obvious bugs, if you just naturally reading from top to bottom, you see a compute average function. Well, let's take a look at this compute average function. Why there's -1? Why there's -1? Why is it starting from 1? Doesn't make sense to me. So compute average, the main idea is just compute the sum, then divided by the number of elements in X. So the ideal way should be we should remove this -1, remove this guy, remove this -1. Oh yeah, that's it. Okay, so let's finish. We just finish this fixing this first function. Let's look at the second function. Oh, obviously this is wrong. This is so wrong. How can you have this indentation within this function? How can you have this indentation of computer max within this computer average? That doesn't make sense to me. Well, what we need to do, select all of them. Now, use a combination, okay, key of shift and tab. See, everything is shift to the left. You don't have to scroll down your cursor and hit backspace a million times. All right, this is a function called compute max. Basically, it will return the maximum of a list of numbers. Well, if you look at this code, this is also very strange. Why does this looping from 1 instead of 0? Doesn't make sense here. If max is okay, so the general logic of the piece of this code here is it tries to create a container that called max, and then it tries to compare every single number inside this x, and trying to see if one of the element in x is larger than this container, it will try to replace the container with the number. So obviously we should not have this +1. And another thing is, if we put some number like this, perhaps, I don't know, a billion, then I don't think it will return anything useful, right? You are actually not getting the maximum number inside of the array x. So instead, what you should do, you should start with a negative a billion, perhaps a really negative number, a really negative number, and then once you do the for loop, you should be able to figure out what is the maximum number of x instead of just a billion. Okay. All right. This is easy things to fix. Okay, for this part, compute bending stress. My memory for my undergraduate education, especially on the solid mechanics part, has been a little bit fading away. The good news is this piece of code is correct. I can tell you, there's nothing wrong with this. Okay, so about the computer rectangular first moment of area. For this piece of code, okay, so for this piece of code, if we look at the docstring, and let's just assuming the docstring is correct, I think what it means here is the square of the height, half height. If that's the case, then this is not correct, because it's only squaring the numerator, okay, not the denominator. Okay, so we should have another exponentiation operation with 2 square, basically right here for the height. All right. How about this one here? Okay, so for this one, compute rectangular shear stress. So if we look at the computed rectangular first moment of area, well, if we go back and take a look, the second argument is width, and then the third argument is height. But in this case here, we kind of switched left to right, right? So the first one seems to be height, and the second one is width. So obviously this is wrong. We should follow the function signature by swap them. Okay. All right. About this one, compute rectangular moment of inertia. I remember there's a factor of 12, but I don't think that you should use double slash. If you use double slash, what does double slash mean? Okay, double slash means floor division, which means you're gonna get an integer at the end of the days. Obviously, this is not what you want. Okay, so we're gonna remove it and make it back to a single slash. All right. For the rest of the part, I don't remember too much on the bending stress, but fortunately these are correct. Okay. All right. So now let's get our first job done. Get the launch code. Okay. So to get the launch code, make sure you have you're not inside the debugger. Okay. Obviously, I'm not. Then you wanted to run debugger file. Hit this button only once. Wait for a few seconds. uh, okay. So now we are going to move to here. Okay, so how can we get here? Well, we can put our cursor here. That's one way. Another way is continue execution until next breakpoint. Well, because the breakpoint is 205, so if I hit this button, I should be able to arrive at 205. Okay, let's see if this works or not. Right now I'm in line 1. Okay, I'm gonna try hit only once. Bingo, I'm right here. Well, actually I'm at the 206. Okay, good. So can you tell me what is the I here? Well, if we read the hint here, it says it says once you're in the debugger, you can use P to print the value of a variable. Okay, how should we do that? Well, fortunately, if you're using Spyder, you don't have to do that. You can just click Variable Explorer. Very easily, you can see the number by yourself, which is a really long string of number. But anyway, let's follow the instruction. We can just use P. Okay, P space, then type the variable that you wanted to that you wanted to get the number. Well, I think in this case we want to get the launch code, so I'm going to say P launch code. Okay, it gave me a bunch of number which doesn't mean anything to me, but anyway, I'm going to just write down the code here. Okay, so now I finish the first half about getting the launch code after the function being called 1,000 times. Next, what I should do is to wait for the function get launch code being called 2,000 times, then get another launch code. Okay, so next, because I have already written a breakpoint, I can ideally, I think if I hit this continue execution until next breakpoint again, I should be able to get that launch code. I should be able to jump right in the 2,000 iterations. Okay, let's see if it works or not. Okay, so I just hit it again. It looks like I go back here. Let me see what is my I number. Oh, hooray! That's great. My I number is 1,999, which is exactly what I want, right? So now I want to get the launch code by type P launch code. This is just one way of doing this. You can just hit launch code. It will also print it out. Okay. The reason when you hit the launch code, it will print it out is because we are actually using an interactive version of the Python debugger. Interactive Python debugger is basically the longer name for IPDB. Okay, because we are in interactive mode, you can just type a variable, then hit space, you get the number. But if you are not in an interactive mode, let's say 10 years later, you work for some software company, you don't have access to an interactive environment, you don't have an IDE, the only thing you have is a boring terminal. And then in that case, I'm sorry, you have to use this little p to print out the number. Okay, anyway, I'm just copy this code right here. And now I'm going to sum this number together. Okay, I'm going to sum these two numbers together to get the code. Okay, so this is the final code. Okay, so I'm just say final code is this. Great. Now I have finished this. I want to stop debugging and jumping out of this. Okay, so now you see if I hit stop debugging, I am the console, the prompt for the console becomes something like int2 or something. No longer IPDB. This means you have successfully jumping out of the debugging mode. Okay, so this is the code what we have. I'm gonna fill the code. I'm gonna put the code right here. Okay. Replace this 2110. I don't know what does that mean, but anyway, we have the launch code. So next, what I'm going to do is I'm going to launch a rocket. Okay, the way you launch a rocket, you just hit the green button here. Sorry, I should actually remove all this. I should remove all this. Okay, so after I remove all this, I'll jump out of it. Okay. Okay, great. Once you hit the green button again, you say congratulations, you have successfully launched a rocket. Great. So it means we have launched a rocket. Perfect. All right. So you can also try a little bit of bonus, trying to figure out if there are some extra challenges. There are some extra challenges. Basically, it related to those bugs I mentioned in the previous functions. And if we just turn it to true, you will find out. Okay, this is not working. Okay. So as you can see, okay, so if you read the message here, it says line 273 is not working. Basically means this other statement is false. Okay. Okay, let's take a look. What's going on here? Because I think I have done everything correct. What's going on? Okay. So let me just click a breakpoint. Start my debugging mode. Okay. Then I wanted to see what is max stress, shear stress. Okay, that's 3.7499. Okay, how about this guy here? Well, this guy. Oh, okay. This guy is 3.75. They are very close, right? They are very, very close. Which give me a hint. Maybe I'm right. Maybe it's just some sort of numerical error. Okay, let's take a look at how do we actually compute a max shear stress. Well, max shear stress, if we go back, now you can just double click using your mouse to double click this max shear stress. You see something is highlighted, right? Okay, this is basically telling you where it appeared. Okay, so let's go back to where it actually come from originally. Well, it comes from this line about computing max and shear stress. Well, if you still remember, if you have a really good memory, you should be able to tell me computer max is nothing but just find the maximum number of a list. So that means shear stress is a list. Shear stress is a list. I want to print it out. Okay, shear stress is a list. How many of them? 200. Where did you see the 200? I see 200 here. 219, line 219. I see I discretize the neutral, this variable here, discretize this by 200 pieces. Looks like this is actually a discretization of the space. I'm actually using a maximum computer max function to get the maximum value. Well, then it immediately tells me if I increase the resolution of my discretization, I should be able to decrease an artificial numerical error by finding the wrong maximum number. By decreasing the numerical error for finding the right maximum number. Okay, so in this case, you need to, for this specific problem, I'm sorry, you have to add a lot of zeros, not just 200, but I don't know, 2 million something. Anyway, if you try a really large number, you will see. Let's go back. Okay. Oh, sorry, that's too much. Hold on, because my computer is frozen. Okay, let me just reduce one. Okay. All right, and again. Okay, great. What this means? It means congratulations, you have successfully launched a rocket. And remember, I have turned this one on, enable boosters. Okay, so that means all of these things here has been checked, and nothing wrong is happening. Okay, so this is how you finish this ICE in a perfect sense. Well, if you want, you can also plot the figure, just in case, if you're interested. The figure should be here. I don't know why I'm not getting. Okay, so this is a figure. I'm sorry, I can't remember too much of it, but I hope it rings a bell for you. Okay, that's pretty much it. I want to talk about for this ICE. I hope you learn a lot of things about Python debugging, and I will see you in next video.